This is your video for Variables and Patterns Investigation 3.2, where we are going to be continuing the discussion of looking at data or information in three different ways, which is the equation, the table, and the graph. And at the very top, you see the learning target, where now we're going to be specifically looking at how to find the rate of change. So now we're going to be looking for a very key piece of information, but in those three different forms. But before we do that, we need to start off with some vocabulary. We're going to be looking at y equals mx. And this is an equation, and it is an equation that makes a line. So make sure you're writing in definitions. In this particular equation, right now it is currently all variables. Whoa, sorry guys, I'm still getting used to this program. Here, the m will be a number. So you might want to make a note of that. So let me give you an example. An example that follows the y equals mx format would be y equals 7x. So there you can see that the m was replaced with the number 7. The x and the y represent the x and the y on your coordinate grid. So if I were to create data with that x and the y, I would make a line because it's following that equation. The second word that we need to look at is coefficient, and understand that in the above equation that the coefficient is the m, and in the example that was given in the previous one, y equals 7x, that the 7 is your coefficient. So it's the number before the variable. And if at any point you need to pause it to make sure that you are getting the information down, please feel free to do so. All right, the last word that I want to look at for this particular lesson is rate of change. And rate of change in the equation y equals mx also happens to be the m. So m is the coefficient, but it also tells us what the rate of change is. So in the example that I've been using, y equals 7x, the rate of change would be 7. But more specifically, it means the change in y values as, it's supposed to be an S, as x goes up by 1. And we'll take a look at what that looks like both in a graph and in a table. So these next ones, we want to look at a couple different relationships. The first relationship is the cost of an adult movie ticket, and then speed limit on the highways. And without any numbers in either of those relationships, you would be unable to make the equation. So I am giving you guys the equation in this example. It's nothing that you would be able to pick out with the information. So I just want to tell you kind of where I'm coming from. So the equation that I'm going to give you is that C, or the cost, is equal to 12m, where m represents the movie tickets. And it is always important to know what your variables represent. So I would like you to label C. Let's take a look at an example now and walk it all the way through from table, graph, equation. So what I would like you to do is looking at the distance traveled at average speeds to go ahead and calculate out where there is a gray box. So go ahead, pause your video, and when you come back, see how you did, and I'll have it completed for you as well. Alright, so you may need to pause the video if you need to double check, but take a look and see if you've got correct distances traveled for each time or each hour right here. If you're not sure how these numbers were found, then what you would need to do is here it says the distance for speed. This is where I'm reading. Distance for speed is 50 miles per hour. So in 0 hours, you went 0. You didn't go anywhere. 0 miles. In 1 hour, you go 50. 2 hours, I double it, I go 100. In 3 hours, I go 150. 4 hours, I go 200. Now, the second and the third column change because your speeds change to 55 and to 60. So make sure that you have those numbers correct on your notes. Now what we need to do is take those 3 different sets of data and make a list of ordered pairs or coordinates and put all 3 of them on this coordinate grid to the right. And you can see that I recommend different colors. So if you do not currently have different colors, I would pause it, see if you can locate some, or maybe use different patterns. So one line you could do dots, or maybe do some sort of dashes. In this case, I wouldn't even care if you did something like this, just so that you could see the difference, although that technically is, I would not want you to graph for accuracy that way. So first thing that we're going to do is list the ordered pairs from the table on the front. So from the first column, we had 0, 0. We had 1, 50, 2, 100, 3, 1. Okay. Not really sure what's going on there. 3, 150. And 4, 200. Alright, pause the video, make your list of the next 2 columns. And then when you come back, you can compare it to what I have. Alright, there are the 3 different lists, and you can see I used 3 different colors. See how you did. Now mine is going to get a little squished here. But the next step is to graph and to make sure that we have the labels that we need. So I have my x-axis. Whoa. Sorry, guys. I have my y-axis. And we need to determine what the x and the y mean. Down here are independent. Remember, that comes from the first column in your table. And that says time, and we do want to be specific here, and we are talking about time in hours, or H. So you do want to make sure that you include that. And then our other thing was distance in miles per hour. So I'm actually going to write it down here and then draw an arrow. If you have space, please put it closer to your y-axis. So miles per hour, and that's for right there. Okay. All right. And before we can graph, we know that we start at 0, the origin. And we need to pick an appropriate thing for the numbers counting up. So if we look back at what we have, we've got to look at the x numbers here. So 0 through 4 in all of these columns. So we don't have to count very high. So I think to give myself a little bit more space, I'm going to actually skip and say that that's 1, 2, 3, and 4. And I still didn't even use all the space I had. Now it gets a little bit more complicated when we want to talk about the y-axis here, because now all of a sudden I have everything from 0 right here to 240 right there. So I've got a bigger span of numbers. So I think that I am going to count by 50. So this first dash would be 50, this one would be 100, that would be 150, that would be 200, 250, 300. So I probably could have even gone a little bit lower, but that's what I went with. All right, now take some time, go ahead, pause the video, and use either different colors or different patterns and graph the 3 sets of ordered pairs. All right, there you can see my dots, and it was a little tough on here because my y, the way I set up my y-axis, they were really too close. So my dots are really close and not even graphed 100% accurately. But what you can see is that the red, the purple, and the green, they are following a line because they're graphed in a line. So what that means then is if we go back to the vocab that we had on page 1 at the top, is when they form a line, it's going to have the equation in the form y equals mx. So the last thing that we want to do is create an equation. And again, each time it needs to be in this form, y equals mx. So for each one, you could, and remember, m is a number, so each of these we could initially set up, because the y is always going to stay in the same place and the x is always going to stay in the same place. So we need to write an equation to show how the distance d and the time t are related. Now, d, distance, if we look back at our graph, the distance was the y. So in this case, I could have the y or the d, and then the x could also be a t. Remember, those variables can change. So if it's 50 miles per hour, my coefficient, or my m, is 50, because that is my rate of change. For every hour, I increase or I change by another 50 miles. For 55, my coefficient, or the m, is 55, because my rate of change is 55 for every hour that I go. I've gone an extra 55 miles. And then last, my coefficient would be 60. So the biggest thing is that these numbers, these coefficients, or the M value in our form is also known as rate of change. And it's by how much something changes or how much something increases. It could also decrease, but for right now we will look at positive examples.